Hello friends, welcome back to our channel. So in today's session we'll see one more concept in discrete mathematics, that is a binomial theorem. So in our previous sessions we have seen the complete introduction to combinatorics, so where we have studied about the permutations, combinations and permutations with repetition and constraints and combinations with repetitions and constraints. So now we'll go with the another concept, that is a binomial theorem. So let's start the session. So what is a binomial theorem? So this theorem is mainly used to find the expansion of any binomial equation or expression, as well as in order to find the binomial coefficients. So now the question is, what is the coefficients, binomial coefficients? So for example, if there is any term, okay, any term like 3x square, so then this particular 3 will be calling it as coefficient. Okay, so the equation, if there is an equation in this way, 3x square plus 4x plus 5, so that implies this is 1, 2, 3, so total 3 terms, where 3, 4, 5 are called coefficients. So mainly this binomial theorem is used to find this expansion and this coefficients. For example, let us take, we all know the formula a plus b whole square. So this is not an expansion, right? So this is not an expansion. So if we expand this one, we will be getting some equation, quadratic equation. See, a square plus 2ab plus b square. So this is called as expansion. Okay, so if this particular expression inside the parenthesis we are having only two terms or two variables, we will be calling it as a binomial. Okay, we will be calling it as a binomial. So if we are using a plus b plus c whole square, okay, so this is not a binomial expansion. I mean, this is not a binomial expression because we are having three terms inside the parenthesis. So now our concept is of binomial theorem. So any kind of expression in this way, how can we expand and how can we find the coefficients? So in exams we may get a question like asking, so what is the coefficient of some x power 4 in 1 plus x whole power 9? So we need to find out the coefficient of x power 4. So first we have to expand this one and finding of quotient of x power 4. So the main thing is, first we have to expand this binomial expansion. The formula which is used to expand the binomial expression is called as a binomial theorem. So let us see. I'll write the formula of binomial theorem, and before that we'll see. So let us take a plus b power 1, which will be a plus b only. A plus b whole square is equal to a square plus 2ab plus b square. Similarly, a plus b whole cube is a cube plus 3a square b plus 3ab square plus 3b cube. And see, the same way we can also find 4, 5, power 4, power 5 and so on. So you can see every time. So remember one thing in this expansion. So this is a binomial expression and this is a binomial expansion. Okay, we are expanding the expression. So here we are having whenever n is equal to 2. So for example, let us take it n, power of n, right? See, a plus b whole power n. A plus b whole power n. So if n is equal to 1, the number of terms, as just I have said, what is a term? So this is one term and this is one term. So how many terms are there? Number of terms are 2. And if n is equal to 2, number of terms, how many terms are there from this example? 1, 2, 3. And n is equal to 3, the number of terms are, how many terms if n is equal to 3? 1, 2, 3, 4. 4. So if n is equal to n, if n is equal to n, then the number of terms in expansion, in binomial expansion, is n plus 1. So if we are supposed to find some expansion like a plus b whole power n, this will be having n plus 1 terms. That is the first point you have to remember. Okay. Second point, you can observe here, in the first term, a is with n, a power n. Okay. In the second term, you can observe a is power 1 and b power 1. And in the third term, b power 2. And coming to here, what is a power? 3. Okay. And here, 2 plus 1, again 3. So a power 2, b power 1, 3. A power 1, b power 2, 3. B power 3. So that means every term, if you add the terms, I mean the powers of every term, it should be equal to n. That's the second point. First point, this one. And the second point, adding powers of every term should be equal to n. You can take any term, the power should be n. So here n is equal to 2. Right? First add the powers. So there is only one power, 2. Okay. Second term, add the powers, a power 1, b power 1. So 1 plus 1, 2. Okay. So b power 2, only one term. So the power is 2. Right. Coming to here, a cube, only one power. So here it is n is equal to 3. And here a power 2, b power 1. So powers are 2 and 1. 2 plus 1, it's 3. A power 1, b power 2. Powers 1, 2. 1 plus 2, 3. B power 3, 3. So the second point is adding powers of every term. Adding powers of every term should be equal to n. Okay, should be equal to n. So the next one, so according to this, you can see first term a power n, second term a is decreased by 1 and b is increased by 1. So here, for example, you can write it a cube b power 0 plus 3 into a square b power 1 plus 3 into a power 1 b square plus a power 0 b cube. So what you have observed? So a is keep on increasing, a is keep on decreasing, b is increasing. So initially the b value, the power of b will be starting with 0 and power of a will be starting from n. So for every term, a power will be decreased and b power will be increased. Right? So you can observe this one. The third point we have to remember. So starting a with power n and b with power 0. So the starting term a will be power n and b with power 0, and from the next term power of a decreased by 1 and power of b increased by 1. So here you can observe a start with 3, b starts with 0, and gradually we are decreasing. So that will be processed till n plus 1 terms. N plus 1 terms. Okay, so that is the third point. First point, number of terms in the expansion. Second one, adding the powers of every term should be equal to n. And the third term, starting a with the power n and b with the power 0, the next term onwards, the power of a will be decreased by 1. This should be continued, right? The next term onwards, power of a will be decreased by 1 and power of b will be increased by 1. Right? Now, there are 3 points we have discussed. And this is the coefficients. What about the coefficients? See, coefficients. The coefficients are NC naught is the first term. Okay. So here you can see 3C0. 3C0. Right? Then NC1 will be the second term. NC2 will be the third term. So, for example, you can see 3 factorial by 3 minus 0 factorial into 0 factorial, which will be 3 factorial by 3 factorial, which is 1. So, coefficient of 1. Second one, 3C1, second term. So, which will be 3 factorial by 3 minus 1 factorial into 1 factorial, which becomes 3 into 2 factorial by 2 factorial, so which becomes 3. And NC2, so 3C2, which becomes 3 factorial by 3 minus 2 factorial into 2 factorial, which becomes 3 factorial by 3 into 2 factorial by 2 factorial, which becomes 3, the third term. Next, 3C3, which becomes 3 factorial by 3 minus 3 factorial into 3 factorial, so it becomes 0 and it is 1, so it is 1. So NC3 and so on. So the coefficients will be represented as NC0, NC1, NC2, NC3 and so on. It goes up to NCN. It goes upon NCN. Okay, now hope you understood. So how we are expanding means we have to follow all these process. I mean all these points. The first one, it should have a n plus 1 terms. Second one, the powers of every term should be equal to n. And the third point, so it's the power of a starts with n and power of b starts with 0, and from the next term onwards, the power of a will be decreased and power of a will be increased. And the next one, finding the coefficients, it will be represented as combinations like NC0, NC1, NC2 and so on till NCN. So by remembering all these points, we are defining the binomial theorem as a plus b whole power n is equal to, so we have to add everything, right? For example, let us take this one, the same thing, I'll write it, right? So a plus b whole cube will be written as, so the same formula I'm writing by using all these 4 points. So 3C0 a power 3 b power 0 plus 3C1 a square b1 plus 3C2 a power 1 b square plus 3c3 a power 0 b power 3. So we have written the same thing by using all the 4 points. So the quotients are represented with the combinations like this one, and the powers of every term will be equal to n. Okay, and if the expansion is like, if the expression is like a plus b power n, it will be having n plus 1 terms. So 1 2 3 4 terms, right? Now the same thing I will be writing like this: a plus b whole power n. So if in any case a can be anything and b can be anything, if the expression, if we want to expand the expression, so a plus b whole power n can be written as nc0 a power n and b power 0. So you can avoid b power 0 because it will be 1, right? So next one, nc1 a power n minus 1 b power 1 plus nc2 a power n minus 2 b square plus and so on. The last term will be ncn b power n. So this is the expansion for this one. So the expansion formula itself is called as a binomial theorem. The expansion formula of this particular expression is called as a binomial theorem. So this can be written as a plus b whole power n is equal to, so these are all addition of terms, so that can be represented as sigma. Sigma is represented with the addition, right? So we can go r is equal to 0 to n. So I am taking one generalized variable r, so it can be written as ncr a power n minus r b power r. So you can observe, you can calculate the value of r. If r is equal to 0, then it will be nc0 a power n minus 0 b power 0, so which becomes this one. If r is equal to 1, nc1 a power n minus 1 b power 1, so this is the term. If r is equal to 2, nc2 a power n minus 2 b power 2, so this is the term. So we can generalize the equation, the expansion, in this format: a plus b whole power n is equal to sigma r is equal to 0 to n. So we need to add all the terms by calculating or by substituting the r value from 0 to n, taking the formula NCR to find out the quotients, and power of a should be decreased. So a power n minus r, based upon the r value, the term, the a value, the power of a will be decreased, and b power r. So we are keep on increasing the power of b value. So the 4 important points, once again I will recall: for the quotients we have to use the combinations formula NC0, NC1, NC2 and so on, NCN. And the second one, if the expression is in the form a plus b whole power n, the expansion will be having n plus 1 terms, and then the power of a should be decreased from one term to another term, and the power of b should be increased. And finally, in any term in the expansion, the powers of a and b, the powers should be equal to, the sum of powers should be equal to n. So this is called as a binomial theorem, and mainly this is used to find out the expansion of binomial expressions and finding the quotient of expressions, right? Yes. So hope you understood this binomial theorem, and let us stop here, and in the next session we'll see a few examples how we can expand the expressions and how we can find out the quotients of a particular term, right? We'll see a few formulas and then we'll go with the example problems. So hope you enjoyed the session. If you are having any queries or doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.